online short-term training program on on digitally controlled power converters for industrial and renewable application phase 3 under AQIS scheme from 14th to 19th December, and theme is renewable applications. We already conducted 2 phases previously, and we received very good response. On day 1, we had Dr. Chetan Singh Solanki. He has talked on energy storage, essence of sustainability. Yesterday, we have with Dr. Raghavan. He was talk on grid connected wind energy conversion system. Today, we have Dr. P.V. Thakre from SSBT College of Engineering and Technology. I would like to welcome Dr. Prashant Thakre.
Thank you, sir.
I would like to give some introduction of Dr. Prashant V. Thakre. Dr. Prashant V. Thakre is the professor in ENTC Department of SSBT College of Engineering and Technology. He is having a 24 years teaching experience. He did his engineering from KIT Ramtek Engineering College, Nagpur University. He did his MTech from Maulana Azad National Institute of Technology, Bhopal, in energy engineering. He did his PhD in design, modeling, and performance study of digital controller for solar photovoltaic system from Maulana Azad National Institute of Technology, Bhopal. He has published various research papers in the renowned publication like SCI Journal, Scopus, Web of Science. He is the recognized guide from in electronics engineering from KBC NMU Jalgaon. He has also received a grant of different research projects during his teaching. So, with this, I would like to welcome again Dr. Prashant V. Thakre. I request please deliver your session on digitally controlled converter system for photovoltaic application. So, over to you, sir.
Thank you, Shah sir, for the brief introduction. And good morning to all the participants. Today, basically, it is the third day of the STTP. And I will basically try to cover the portion related to whatever I have done in my research area, as well as the project which I have done basically in our institute. So I will try to discuss about a few parameters which we have considered while doing this project also. So very good morning to all of you. The flow of presentation, my presentation will be, that is, introduction, literature review, problem formulation, methodology, solar tracking system, inverter topologies, modeling of a closed loop system, Simulink models, some experimental setup also I will show you, and finally the conclusion and references. As basically we have to discuss this power electronic system related to renewable energy. So it is very much essential to see what is the scenario of the energy as far as world as well as India is concerned. So I can say that with the growing energy demand and increasing global environmental issues and depleting of the energy sources such as coal, oil, gas, the need to develop and utilize new sources of energy seems inevitable, and we are doing it from the last decade. So therefore, renewable energy sources such as solar, wind, biomass, hydro, and geothermal are appearing as an important alternative energy source option. And solar energy is one of the few clean and abundant renewable energy source which is being used extensively in recent years. Okay, so we can say basically we are seeing also that how basically the technological development is happening as far as the solar technology is concerned. So if you consider the energy consumption by sector worldwide, okay, and try to compare, basically these are three sectors are being considered in this particular slide, that is transportation, commercial and industry. And if you consider the Indian scenario here, okay, you can see that here the energy consumption in India is mostly happening in the commercial sector. Okay, so basically whatever, no doubt, basically there are industrial sectors also, transportation sector also. But as far as commercial sector is concerned, we have to pay more attention as far as the energy consumption is concerned. Okay. So next slide basically shows that how basically we are importing the crude oil, okay, from the various parts of the countries. Okay, where you can see here Saudi Arabia, Iran, Kuwait, Iraq, UAE, Nigeria. Okay, so these are the imports which are happening basically as far as the crude oil is concerned for Indian scenario. Okay. If you see the energy demand projection, means these are the four categories, that is electricity, coal, petroleum and natural gas. And if you consider the year wise, you can see here that is the demand is increasing year to year. Okay. And this is the major concern. Okay. As far as the utilization of renewable energy is concerned, means either you can consider hydro, you can consider geothermal, tidal, whatever it is. Okay, wind, solar. So here basically we have to see that in future how we can minimize this particular demand by increasing the utilization of renewable energy. Okay. This is the type wise total energy consumption in India as percentage wise. Okay, this is CRW, that is combustible renewable waste, then hydro, oil, nuclear, coal, natural gas, and this is ORE. So you can see here the consumption of coal is very high, because everywhere basically if you consider thermal power station means major electricity which we are considering, that is the production of major electricity is due to the thermal power plants. Okay, so somewhere basically we know that coal is depleting day by day. Year to year, we will not be able to get so much of coal in future also. So it is very, we can see it is a serious problem as far as the energy consumption in future is concerned. Okay, so every people have to, as basically in the inauguration session, Dr. Chetan Singh Solanki sir basically gives stress on non-utilization, means you have to restrict your energy utilization, and if you have to use, you have to go to the renewable energy. Okay, so this is the reason why basically we are concerned about the energy consumption. So worldwide, that is, as my work is basically in solar energy, so I will concentrate more on the solar technology. So worldwide, lot of work on solar technology is going on even in the countries where there is a limited, means if you consider the European countries, lot of solar technologies are coming there also, where they have a limited sunshine. Okay, but if you consider the Indian scenario, we have a lot of sunshine, and this technology, solar technology, can flourish more in our continent. Okay, so with the advancement in and one more basically, if you consider yesterday only, our Prime Minister Modi ji has laid a foundation for erecting a very big solar project in Kutch area. Okay, in the desert area of the Kutch. Okay, and if you see the capacity, means according to the news, the capacity of that particular project will be having 30 megawatt production capacity. Sorry, 30 gigawatt production capacity. Okay, and the project is basically, if you consider the area of that project, okay, that will be basically covering nearly 800 square kilometer area. Means you can imagine that 800 square kilometer area means it will be a Singapore. Okay, so much area is being covered by that particular project, which is having a capacity of 30 gigawatt. Okay, and naturally, if you see the future policies of the Indian government, okay, then by 2022, Indian government is planning to have an installed capacity of 175 gigawatt. Okay, and the next step is that till 2030, the installed capacity will be increased to 450 gigawatt. Okay, so we can imagine that what are the basically what may be the scope to work, okay, as far as the renewable energy technology is concerned. So I request all the people who are working in this concerned area, okay, they can have a more exposure to this particular technology. So with the advancement in control techniques, means now if you go slightly interior into these technologies, okay, then as we know that various types of subsystems are required. Means with the help of panels, we can have DC to DC converter. If our loads are AC, then we have to consider inverter. Okay, then there should be a proper control techniques. Okay, so to increase the efficiency or to remove the various unwanted parameters. Okay, so with the advancement in control techniques, solar energy is becoming one of the major alternate renewable energy source for generation of power. So today with the explosive growth and expanding efficiency of digital technology, means naturally we are more concerned about digital technology as it is most efficient as compared to the analog technology. Digital inverter system already it is existing. Okay, but we have to work in such a way that how we can improve these systems more. Okay, that is basically where the challenge is there. So digital inverter system is having an edge over analog system. Microprocessor, microcontrollers, digital signal processors, as far as VLSI technology has been used for the pulse width modulation, pulse generation, and real-time controller of inverter systems. Okay, so when we talk about inverter systems, then we have to have a proper control strategy. Okay, and as far as digital technology is concerned, we have to use these processors for the controlling techniques. Okay. And another thing is that basically in my presentation, I will be stressing more on residential PV applications, residential photovoltaic applications. Okay. Because what is basically the future plan means, as far as what I have read, the central government or the government policies will be there in future to promote these standalone systems. Okay, that is the residential applications. Okay, so in the residential PV application, the types of loads connected to the PV inverters are uncertain. Nonlinear loads could cause intense distortion in the output current and voltage waveform. Therefore, a high performance inverter is required to maintain the desired output voltage waveform over all types of loading conditions and transients. So this is basically the requirement that even if the load is non-linear, we should have an efficient system. Okay, so finally, thus to overcome the energy crisis in India, low power photovoltaic units could be implemented at each rooftop, which could fulfill the household requirement. Also, extra amount of power generated could be fed to the grid. To achieve this, proper photovoltaic inverter system is to be selected with appropriate tracking methods to make system more flexible. Digital control could be used. Means system, if you want to make more flexible, we can use a digital control technique. Okay. In between, if you have any queries, you can also ask. Okay. So whatever we have seen till now, basically it was an introductory part. Then some literature review basically I have done, considering various IEEE and the other journal papers. Okay, so based that is the literature review has been categorized into three types. That is the types of photovoltaic systems, then inverter topologies, and digital controller. So for just in few minutes, I will just highlights what basically some of the researchers has done. So the first paper, basically, if you consider, it has worked on the type of MPPT. Means if you consider the solar photovoltaic system, to extract maximum power from a panel, because we know that the light or the photons which we are receiving for the panel are not uniform throughout the day. Okay, so it is essential that at every instant or every time, okay, we should be able to extract a maximum power from the panel. Okay, so there are different, you can say, methods by which we can extract maximum power from the panels. Means if you consider incremental conductance method, then there is perturb and observation method, short circuit current method, open circuit voltage method. So there are different types of methods by which basically we can extract maximum power from the panel. Okay, and every method has its own logic. Okay, so if you see this paper, then basically in this paper, the MPPT tracking algorithm has been covered. Okay, and in order to solve the problem, this particular paper investigates the effect of non-uniform. Just I told you that the photons are not uniform. So non-uniform solar irradiance distribution on PV source and optimizes the source instantaneous operating power under non-uniform irradiance. Then the another paper basically is considered by for investigating the tracking capabilities, inversion efficiency, and large signal response at different switching frequencies. Means, for example, naturally, whatever MPPT technique which we are using is combined with DC to DC converter. That is the boost converter, buck boost converter. Okay, and with the help of these different types of switching frequencies, we are able to stabilize the output. So that also we will be covering in the subsequent session. Uh, then the third paper basically is comparing, means there is a comparison between grid connected and standalone. The grid connected inverter should operate, means it is basically what dual mode, means you can have that same system as grid connective and you can consider it as a off grid also. So to provide power to the emergency load during system outages. In standalone, the voltage controller is used to regulate the output voltage. Okay. Then there is another paper which has basic means you can consider that the Kepler's problem has been considered. Means there is a Kepton series which is basically considering the optimization. Means you can see a series of values which are coming. Okay, and they are to be optimized so that we can have a proper PWM signal. So this basically paper concentrates more on this particular technique. Okay. Then there is another paper which has improved control strategy for a distributed generation system under standalone mode. As there is no grid supply in the standalone mode, the output voltage has to be controlled with constant amplitude and frequency by the load side. Okay, under balanced and non-linear load condition. Okay. Then there is a bang strategy which is used for switching purpose. Okay, there is a strategy which is called as bang, and that is used for this switching of the power devices which are being used in this DC, either DC to DC converter or the inverter. Okay, then basically, as I told you that when we are considering the digital control techniques or the digital control is being considered, then this digital control is being done with the help of various types of, as I told you, microprocessor, microcontroller, DSP processors. Okay, so this particular paper basically has used TMS 320F2812, which is of Texas. Okay, for generating a proper PWM signal. Okay, with a digital control strategy. Okay. Then there is another paper where basically this paper uses IR digital controller to design 800 watt single phase PV inverter. The photovoltaic inverter system is tested to achieve the design target and get the stable running. Okay. Then of course, there are various types of PWM techniques. You must be aware about that. That is the simple PWM technique, sinusoidal PWM technique, SVPWM technique. That is the space vector PWM technique. So this particular paper has used this sinusoidal PWM technique for generation of PWM signal. And it has also used DSP, that is TMS 320F2812. Okay. This paper has used another DSP, that is TMS 320LF2407. Okay. Then there is, these all papers which I am basically you are considering, these are of using different types of DSPs. Okay. So based on these all papers, okay, we can have a problem statement. Okay. So this problem statement has been categorized as the first is identifying and selecting a proper tracking method. Okay, as I told you that there are various types of tracking methods, MPPT tracking. Okay, one doubt I want to clear, basically these tracking methods or the tracking of the means MPPT tracking is basically not a physical tracking. Okay. Physical tracking is basically by considering stepper motor or motor arrangement, we can rotate the panel. Okay. But this is the second type of tracking where with the help of this algorithm, okay, we could be able to extract the maximum power. Okay. So that we will see in the subsequent section. So identifying and selecting proper tracking methods. In that we can categorize as identifying the solar tracking method for maximum output power, its mathematical modeling, okay, then implementing selected tracking method to a photovoltaic system. Then next is design and modeling of a digital controller for solar photovoltaic system. Okay, so first is identification of tracking method. Second is designing and modeling of digital controller for solar photovoltaic system. So in that we have to develop an algorithm for MPPT and inverter system, and identifying suitable digital signal. Basically, I have used DSP. That's why I have mentioned here digital signal processor. You can use microcontroller also. You can use VLSI technology also. Whatever technology we can use for digital controller. Some now basically some Piccolo series processors are also coming of Texas. So identifying suitable digital signal processor for the photovoltaic system. Then next is development of photovoltaic inverter system, that is design and development of different types of inverter models. Means what suitable model we can use for our particular requirement. Anybody is having any question? Or it is requested kindly mute your mic. Then next is identifying suitable PWM technique for switching, selecting suitable inverter model based on the total harmonic distortion, voltage and current waveform as well as switching frequency. Then development of hardware circuit for selecting solar photovoltaic inverter model and observing the performance of this digitally controlled photovoltaic inverter system. Then next is developing an algorithm for generating PWM signal in Code Composer Studio. This is important. Basically, whenever we are working using DSP, then we have to use a this software tool which is called as Code Composer Studio, where we have to build a project. That particular project will be consisting of various types of files, such as source file, linker command file, library file. All these files are to be considered to build a project. Okay, and with that particular project, when it is being loaded in the DSP processor, and after running, you can generate a PWM signal for your system. Compiling and running the program of PWM generation using basically the processor which I have mentioned here. This basically processor I have used for my particular system, that is TMS 320C28027. This is a Piccolo series processor which is specially used for power control applications. This is of Texas. Interfacing TMS 320C28027 to the photovoltaic inverter system and observing the performance of digitally controlled photovoltaic inverter system. So all these steps are basically considered in the problem statement, and for that we need a methodology. So next is basically how we will go for this particular to achieve these particular points. Okay. The scope of this work is based on considering various parameters of MPPT based closed loop digitally controlled photovoltaic inverter system for residential application. The methodology for carrying out this research work is as follows. These are the various points. That is, of course, study of solar tracking method and identifying a suitable tracking method for proposed research work. Selecting the digital signal processor. Development of mathematical model for solar photovoltaic system with converter and simulation of developed model using MATLAB Simulink. Development of inverter model for solar photovoltaic system and identifying PWM generation technique. then testing of selected inverter model with different switching frequencies and a low pass filter, development of algorithm, generation of PWM signal, then testing of the simulated model, observation of output generated through experimental setup, and comparison of simulated and experimental results. So this exercise basically I have done, which I will be sharing with you. So if I consider a particular system which I have to develop, I will go for this particular block diagram. Okay, where you can see here that if I consider a digital, means for what basically I have considered as digital controller. Digital controller, I have considered it as a combination of MPPT system converter, means of course this converter is DC to DC converter, and a digital signal processor which I have used, that is TMS 320C 28027. So this whole block I am considering it as a digital controller. And of course, if I am going for a renewable energy, I have to consider panels. Here, loads are AC, so I have to consider inverter. And as I am saying it as a standalone system, I have to go for battery also. Okay, so this is the block diagram of the proposed system. Anybody having any query? Some type of disturbance is occurring. So I request you to kindly mute your mic. Okay. This is the block diagram of MPPT control. Now, basically, what MPPT control is for, means how basically the MPPT control works. Okay, every time we have to extract voltage and current from the panel. Okay, based on that, a power calculation will be done, and certain condition will be established time to time. Okay, which will be given to the controller, and from controller it will be given to the power switch which is being used in DC to DC converter. Okay, and of course there will be a charge controller which can be used for the continuous and constant charging of the battery. Okay, we will slightly go into the details of this basically with some few equations. Okay, when we talk about this MPPT tracking system, as far as basically the method of tracking is being concerned, I have used a perturb and observation method in my particular work. Okay, this perturb and observation method basically works on the every time detecting the increase and decrease in the voltage from the panel, and by using that particular values, we can have a particular system, trained system. Okay, we can have a trained system which can predict basically future values as far as the input is concerned. Okay, so that is a prediction. That is a prediction based on whatever earlier we have received the values for voltages as far as the panels are concerned. Okay, so the solar MPPT tracking system, the light generated current, that is whatever photons which are incident on the panels will generate a current, and that is being termed as IPH, that is the photo current. And you know that basically this cell is nothing but a PN junction which we are considering in the panel. It will have a saturated reverse current also, that is ISAT, and the equations for these two are stated here, that is IPH will be equal to ISCR plus KI into T minus TR into S. Okay, and the saturation current will be equal to IIR into T upon TR whole cube exponential Q Eg by K into 1 minus TR minus 1 by T, where this particular T is absolute temperature, TR is the reference temperature, Eg is the energy band gap, ISCR is the short circuit current at reference temperature, K is the current temperature coefficient, S is the per unit irradiation, that is the insolation which we are considering, and IRR is the reverse current at reference temperature. So these are the two basic equations of currents which we are considering for the tracking system. Okay. And for maximum peak power, we have to consider this equation. Okay. And where this I is the actual current. This I is the actual current which we are getting from the panel time to time. I sat is the saturated reverse current. Q is charge on electron. A is the ideality factor. This A ideality factor. देखो सर किसका शुरू है?
सर इनका कंट्रोल ही नहीं अपने पास, महेश कंट्रोल नहीं अपने पास। देखो वो मुझे पता है कहाँ से हो रहा है, लेकिन उनको
You are requested to kindly mute your mic. Okay. So this I is actual current. I sat is the reverse saturation current. Q is charge on electron. A is the ideality factor. Basically, this ideality factor is dependent on which type of panel you are considering. Means it may be a monocrystalline, polycrystalline. Okay. This ideality factor differs as far as material of the cell is concerned. Okay. So this particular area is also very vast as far as the research is concerned. Okay, as far as the study of panels are concerned. Okay, the K is the Boltzmann constant, T is the temperature in Kelvin, RS is the series resistance. And the optimal voltage Vm is used to consider the voltage perturbation given by the equation. Okay, that is, as I told you that when we are considering non-uniformity of the irradiation or insolation, time to time we have to detect this voltage. Okay, so this Vm parameter is dependent on the voltage perturbation or the voltage disturbances. Disturbances, we cannot call it as disturbances, but increasing and decreasing of the voltage. Okay. So slightly we will go on to the systems now, solar PV systems. As I told you that there are two types of systems. Generally, you must be also aware about this. That is standalone system, which is also called as off-grid system, and grid connected solar PV system, that is on-grid system. Okay. These are the simple block diagrams of this off-grid and on-grid system. Grid connected solar PV systems are applicable to the residential houses which are located near to the grid. The basic component of grid connected systems are PV panel. About disturbance.
डाल रहा हूँ documents.
Just I will pause for a while because the disturbance.
Hello, dear participants, you are requested to please unmute your microphone. It is creating a disturbance and unnecessary noise which is disturbing the speaker also as well as all our participants. So it is once again request, please check yourself. I think some participants they may be on the computers and they might have kept their microphone in unmuted condition. So please mute your mic. Once again, please check. The unmuted mic itself is creating some certain noises. So once again, I request, please check all of your mic, unmute it, so everyone can see here. I don't know the name because it can't be seen. Few participants are there whose mic is in unmuted condition, I think. Mr. Mahesh Patil, Mr. Satpal Singh Rajput, Suswan Pramanik, please check your microphones. Mr. Mumin Shehbaz, please unmute your. All of you are requested to please unmute your microphone. Okay, sir, you can start, sir.
Thank you, Vani sir. So sorry for the disturbance. We will continue. So there, as I told you, that there are two types of systems, that is off-grid and on-grid. So these are the block diagrams of on-grid and off-grid system. So the difference basically is only of a battery and charge controller. That is, if you consider off-grid, we have charge regulator unit here, battery here. Okay. If you consider the fundamental principles of inverter, as we know that if you consider a non-linear load, that is inductive load, then there will be a phase difference between current and voltage. And based on basically the work of inverter can work in 4 modes. Okay, 4 quadrants. So out of that, first and third means if you consider this first and third mode, okay, where in one case both voltage and current are positive. Okay, if you see the first mode, both voltage and current are positive, as well as if you consider the third mode, both voltage and currents are negative. So these can be considered for inverter operation. Okay, and if you consider this second and fourth mode, where in first case voltage is positive and current is negative. Okay, and in second mode we have current positive and voltage negative. So in that case, this circuit can work as a rectifier. Okay, this is very basic principle of this inverter, where we can have a bidirectional power flow. And as far as the standalone system is concerned, the requirement is that it should have a bidirectional power flow capability. Okay, so this is basically the basic principle of the inverter operation. Then there are
Thakre sir, one question.
Yes, yes.
What do you mean by standalone system? Because I am not of electrical background, so
Yes, standalone system means there are, as I told you, that there are two types of systems: standalone and grid connected. Any system which is being connected to the grid, grid means from where we are taking supply, that is through MSEB, means electricity board. Okay, so when we are installing such type of systems, there is a net metering concept coming into picture, that whatever generation which we are doing at our part, okay, that has to be submitted, means that is to be fed to the grid through a net metering. Means you must be knowing the units, number of units getting consumed. You must have seen electricity bill.
Yes.
So number of units which are being consumed. Okay, that in case of on-grid system, that is the grid connected system, whatever generation which we are doing, whatever generation of units which we are doing, that is to be fed to the grid, और वहां से हम लोग utilize करते हैं. Okay, but as far as standalone system is concerned, we are erecting our own photovoltaic system. Means we will be generating our unit, means we will be generating our electricity, and we will be consuming it. We will not go for the grid. Getting my point?
Yes, thank you, sir.
Okay. So as far as these inverters are concerned, there are many types of inverters. Line frequency inverter, high frequency inverter, transformer isolated inverters. So many types of inverters are there. So out of that, basically I have selected a high frequency inverter for my work. That is the transformer isolated. Even inverters are also categorized according to the stages. That is single stage inverter, double stage inverter. And of course, when we go for a bidirectional power flow, we have to consider two-stage inverter. Okay, so the transformer isolated high frequency link inverter I have considered for my work. Okay, this is the circuit diagram of a bidirectional high frequency link inverter, where there are two stages, two converter stages. You can see here, this is one converter stage and this is another converter stage. Okay, high frequency PWM bridge and polarity reversing bridge. Okay, and it is of course having a bidirectional power flow capability. Now, some analytical modeling has been done for this particular inverter, that is the high frequency link inverter. Because whenever we have to consider means for building a project, okay, you have an algorithm or you have a source file, okay, where we have to consider all these parameters. So for that, some analytical modeling has been done. This is the equivalent circuit for this bidirectional high frequency link inverter. Okay, and this has been analyzed by considering simple KVL operation, and these equations are being generated for this particular model. It is arranged in a matrix form, and some assumptions are being made here. Basically means whatever that is also other equations which are expressed, means you can see these equations, the values of RL and RC are assumed to be very small and are neglected. Thus equation can be modified here. As this equation, I will not go into the details because this is basically the total derivation, okay, through which these equations are being derived. And based on basically this equation, this model has been prepared. Okay, this is a dynamic model. So you can consider that whatever the circuit diagram which we have considered for that particular bidirectional high frequency link inverter, that is being converted into a dynamic model with the help of equations. So based on the equations, a dynamic model of the system is represented by this block diagram. But of course, this is considered for an analog, means you have to go into the discrete also, because you have the type of controller, means controlling technique which we are considering is digital control technique. Okay, so these equations or this model has to be converted into a discrete form. So for that, these are the equations. Since the control is, as I told you, that since the controller is to be implemented using a digital processor, the continuous time space equations are converted into discrete form. So the discrete time state space equations with sampling period of TS are represented as these equations. Means whatever equations which we have considered earlier, that has been converted into time space state space equation. Okay, there are some coefficients which are being considered. So that can be calculated, means A, B, BD and C. Whatever we are seeing in this particular equations, these are coefficients which can be calculated as like this. Okay, and based on that, a discrete time equations can be generated, which are represented as these two equations. So we can say that from equation it is observed that additional disturbances term appear, okay, due to the discretization of the model. So as compared with continuous time model, there exist two disturbances acting inductor current and output voltage. Okay, so that disturbances can be considered as a feedback parameters. Okay, so further you can see here the current and voltage disturbances are represented by the equation. Now from this equation, what are the voltage and current disturbances that I have categorized here? Okay, and from this, basically I have prepared a discrete model. Okay, this was basically, if you consider the earlier one, this was an analog model, and this basically is the discrete model which I have to implement it in my controller. So based on the above equation, the digital model is represented by a block diagram as shown, where Z inverse is nothing but the unit delay. Okay, so this was basically the discrete model. Now we have to go for the closed loop system also. Okay, because this whatever parameters which we have considered in this term, I am till this particular time I am considering it as an open loop system. Okay, but next step is basically to consider or to implement a closed loop system. So for design and development of digital closed loop controller, output voltage and currents are sensed and fed to the ADC, which improves the switching sequence of the power switches. Means the concept behind it, that is, means we have to improve the switching technique. We have to increase the switching instant. So for improving the switching instant, time to time we should get the feedback from the output, that is the voltage and current we have to sense. Okay, and by sensing that voltage and current, okay, we can improve this switching instant. Okay, so for that a control strategy is required. and it can be categorized as current loop control and voltage loop control. Okay. So these are the concepts of current loop control and closed loop voltage control. So here basically this is showing the equation for that, means what should be the limitations as far as the current loop control is concerned, and what should be the limitation for closed loop voltage control is concerned. Okay. So this was all about whatever control technique or the control strategy which we are considering for a particular inverter. Okay, after converting it into a discrete model. Now, next is that we have to establish a Simulink model for that. So the MATLAB Simulink models have been developed for MPPT system, boost converter and inverter. Okay, because these are the three major parts as far as the standalone photovoltaic system is concerned. For development of MPPT system, perturb and observation method has been used, which I have already told. A closed loop boost converter has been implemented. For selecting inverter, different types of inverters have been developed and simulated. Means actually some inverter models were studied for this different inputs. Okay, but majorly which I have told you that I have used this bidirectional high frequency link inverter, that is the BHFL inverter. Then this is basically the Simulink model for this solar photovoltaic cell. You also must be aware about this VI characteristic and PV characteristic of any particular cell. Okay. This is basically DC to DC boost converter. Okay. So where basically you can see here, this is the closed loop control. This is basically a PI control. Okay, which is being used. Okay, to stabilize the output of, means it is basically a model where I have tested with one model, because the major thing is that the work which I have considered is for 500 VA. Okay, but before that I have basically tested these models with initial inputs, and then I have gone for this 500 VA. Okay, so this is basically DC to DC converter, that is the boost converter. Okay, then you can see here, this is the logic of perturb and observation method. Okay, because I'm sorry that this is basically not that much clear. Okay, but you can see here, this is basically the boost converter which I have used earlier. This one. Okay, this is the DC to DC converter or the boost converter. This is the panel specification. Okay, where I have inputted certain parameters for the panel such as insolation, then what is the maximum voltage, maximum current, then VOC, ISC, all these things. Okay, based on the required input. Means if I am considering 500 VA or 500 watt capacity, of course, the panel should have also a generation of nearly 500 watt. Okay, this is the what you call it as a directly proportional. Okay, जैसे आपको 1 kVA 1 kVA का सिस्टम या 1 किलोवाट का सिस्टम आपको इरेक्ट करना है, तो यू शुड रिक्वायर 1 किलोवाट पैनल्स आल्सो. Okay, so and this is basically inverter. This is a inverter, and this is whole logic of perturb and observation method. Okay, these are I will not go into the details of these small models of inverters. Okay, by using these inverters are tested with different types of switching techniques. This is a simple pulse generator. Then this is with the PWM generation. Okay, without feedback. This is that is you must be aware about the switching. That is there are two types of switching techniques, that is unipolar and bipolar switching techniques. So this basically, this is the logic of unipolar switching. Okay, then this is the logic of bipolar switching. Okay, this is a 180-degree mode inverter. Okay, then there, now see here, this is basically my inverter, that is bidirectional high frequency link inverter, which is being considered with the help of unipolar switching. Okay, and this is basically a complete model which is being considered. Okay, you can see here the number of panels which are being considered: 1, 2, 3, 4, 5, 6. Each of 80 watt is being considered. So of course, input we are having nearly 500 watt. Okay, and this is basically DC to DC converter. This has been summarized in one block, whatever I have shown you before. This is basically DC to DC inverter. Okay. So if you consider the results of this modeling, Simulink model, then we can summarize these results with a discussion that the performance of different types of inverter systems have been studied with respect to the photovoltaic input using Simulink models. A prototype inverter system for 500 VA has been developed and its results are studied and verified. And for studying, means basically this we will see in the subsequent presentation. For studying and verifying the prototype hardware model and advanced digital controller, TMS 320C 28027 of Texas Instrument is being considered. Okay. So initially, this is just a summarization of whatever we have studied till now. Initially, the performance of solar cells was studied by using a Simulink model. After that, the characteristic of solar panel considering arrays of panels was also tested with the help of MATLAB Simulink model by considering parameters such as insolation, short circuit current, this should be open circuit voltage. The characteristic of solar panels were obtained with the help of algorithm and programming. This is basically the MPPT curve, that is the VI characteristic. Okay. For a particular panel which I have tested. Then some validation was being done. Okay. This particular method which I have taken from a particular paper. Okay. So I have validated my readings with that particular paper, result of that paper. Okay. So here we can see that, of course, we are getting similar results. Okay. As far as the VI characteristic is concerned. Okay. Then this is the power characteristic, that is the PV curve. Okay. Where voltage, power, voltage and current, it is being stabilized slowly. Then how to extract maximum power. Okay, because this is not only a one curve, every time we will be getting such type of curve. Okay, maybe in different readings. So every time we have to detect this particular point where we have to where we are getting a maximum power. Okay, and that can be then processed further to DC converter. Then there is a output power for boost converter which is being stabilized. This is for a single panel. Nearly it is reaching to 80 watts. Okay. And this is the output of a complete system. There we can see here the voltage I am able to get nearly, means you can see this is the 500 watt reading, where we are getting near, we are reaching near to that. Okay. Then current. Okay. So these are the output of a photovoltaic inverter system. Then one exercise basically I have done by considering different switching means once the model has been prepared, I have tried to improve its total harmonic distortion. Okay, by considering different switching frequencies. So I tested that model with different switching frequencies. Okay, so I have considered these values as 1 kilohertz. Then the THD was basically somewhat higher than 5. Okay. Then it was 2 kilohertz, then 5 kilohertz, 10 kilohertz. Okay. So I have tested the output as far as the different types of switching frequency is concerned. Okay. And I was able to achieve this THD below 5, that is 4.65. Okay. So these are basically the values of THD which I got by changing the switching frequencies. Okay. So next is basically the same I tried for the hardware. Okay. So in case of hardware, these are the hardware specification which I have considered for my model. That is the panel which was being considered, that is it was SLP512. This is the model specification with a rated power of 100 watt with rated voltage 17.5, 5.45 VOC ISC, and considering insolation value of 1000 watt per meter square. Okay. Then the battery which I have considered having 12 volt 7.2 Ah. Then there was an IGBT driver, means a driver circuit, which I have considered. Then filter specification, filter values consisting of inductor, resistor, and capacitor. And finally, the digital controller, that is the Piccolo series controller, TMS 320C28027. Okay. So these are some of the arrangements basically of my hardware. Okay. This basically you can see this is the controller, that is TMS 320C28027. Okay, which is having a base station and a chip mounted here. Okay, so it was mounted basically on one platform. Okay, so this is the control card, this is the driver circuit, this is the inverter panel, battery. Studying the output of this hardware, that is some calculations were done, okay, for minimizing the THD. So I have used certain formulas for calculating the THD. So for that, I will not go into the details of this because we have some more slides. Okay. So there are some calculations here. That is the selecting of switch is based on the calculated values of current rating. That is resistance value was calculated. Then selection of transformer based on means how many number of turns we have to consider. Okay, so transformer was also being specially designed for that. Okay, then based on that the THD was calculated. Okay, somewhat this THD was very high in the earlier case. Okay, but by considering this switching frequencies and using a low pass filter, I tried to minimize this particular THD. So considering the switching frequencies, you can see this is the table, means how this switching frequencies are affecting this THDs. Okay, so 1 kilohertz it was very high, that is 78.74. Then till 10 kilohertz it came to 43.34. And after that, again a low pass filter was being used. Okay, so by considering the values of L and C, by properly selection of the L and C values, it was able to, I was able to minimize that particular THD. Okay, these are some of the observations which I have basically observed on the DSO. Okay, reference and carrier signal. Then this was the observed PWM signal. Okay, which I generated from my control card, that is TMS 320C28027. Okay, then this was the generated AC current and voltage for the resistive load. Okay, then experimentation and simulation results for voltage and current waveform. Now basically there was a comparison made. These are the upper graph shows the result which I got from the hardware, and this is the lower result shows the simulated results. Okay, and the conclusion can be drawn from these two results as the power change due to the change in photovoltaic voltage and current, as well as change in amplitude due to variation in insolation and temperature per turn and observation method has been identified and selected. The present work contributes in developing a continuous tracking capability for extracting maximum power. The model identified the maximum output power of 80 watt. The voltage and current at maximum power was 20 volt and 4 amperes. Okay. To maintain output voltage and current to a desired level, a model of converter with digital controller has been simulated. Okay, there was a simulated model. The maximum peak power tracking with converter has been tested with different values of insolation. Insolation means whatever radiations which we are you must be knowing that this insolation value differs according to your longitude and latitude. Okay, so of course in India, on an average, the insolation value which is being considered is 980 watt per meter square. Okay, it differs based on this different longitude and latitudes in different countries. Okay, the MATLAB Simulink model of a complete photovoltaic system consisting of a solar panel, maximum peak power tracking system, converter and inverter is simulated. Okay. The AC output has been having voltage equal to 240 volts and no load current equal to 2 ampere. The selection of inverter for digitally controlled photovoltaic system.
Hello. Ah.
Yes. So, were you able to hear my voice?
Yes, sir. Now it is.
Yes, sir.
No, then from how much time you were not able to hear it?
Just 10 seconds, maybe 10 or
Okay.
15 seconds.
Okay. Fine. Okay. So to maintain the output voltage and current to a desired level, a model of converter with digital controller has been simulated. The maximum peak power tracking system with converter has been tested with different values of insolation ranging from 900 watt per meter square to 1000 watt per meter square. Okay, it has been observed that the converter is maintaining the desired level of the output. Then a MATLAB Simulink model of a complete photovoltaic system consisting of a solar panel, maximum peak power tracking system, converter and inverter is simulated. Okay, this already I have discussed. The selection of inverter for digitally controlled photovoltaic system has been done by simulating various inverter models. Models such as single phase full bridge inverter. These are the different types of inverters, okay, which we have seen basically. Based on their fundamental values and percentage THD, a high frequency link inverter has been identified for digitally controlled photovoltaic system. That is, as I told you that I have considered this high frequency link inverter. Okay, this the conclusion basically we can draw is that the selected inverter model has been tested with different switching frequencies ranging from 1 kilohertz to 10 kilohertz. And it is observed that at 10 kilohertz, the selected model achieved THD equal to 4.65% for a resistive load, 9.87% for inductive load, and 11.49% for capacitive load. Means this I am talking as far as the hardware is concerned. Okay. So after simulating, testing and observing the output signals of various Simulink models, an experimental analysis means the hardware model was prepared for 500 VA rating. Okay, the controlling signal for maximum peak power tracking system converter inverter were generated through advanced flexible and economical Piccolo series processor. Okay, as I told you that it was a Texas Piccolo series processor. Okay, TMS 320C 28027. Okay, and the output was observed by using this particular storage oscilloscope DSO. Okay, so these are basically the readings. And finally, we can see that the development and study of digital controller for solar photovoltaic system has been studied and tested successfully. Okay. Yes. Now, this was basically the work which I have considered during my research work. Then after that, I worked for certain project. Okay. So just in 5 or 10 minutes, I will try to show you that basically how we have installed 1 kilowatt standalone system in our department, which is running very successful in from last 3 years. Okay. So this is basically that particular system which is being considered using this particle swarm optimization technique. So the idea behind this, you must be knowing that particle swarm optimization technique is basically the optimization technique where the system is being trained, okay, based on the repetitive sequence which are happening. Means the picture I have basically shown you is the birds. They are searching for food, okay, and there will be as far as these birds movement is concerned, there will be basically a leader who will be guiding the other birds. Okay, so whosoever is the leader, okay, that leader will search for food and the other birds will follow them. So basically this concept is being considered for this optimization technique, which is called as particle swarm optimization technique. Okay. So this PSO basically is a stochastic optimization technique proposed by the persons who proposed this particular technique. A population-based search method with the position of particle is representing solution and swarm of particles as a searching agents. Okay. So PSO is a robust evolutionary optimization technique based on the movement and intelligence of swarms. Okay. PSO finds the minimum value for the function. So there is a comparison as far as the parameters and the movement of bird is concerned for this particle optimization technique, but I will not go into details of this. Just I want to tell you that these are the basic equations which are being implemented in that. And this is basically the implementation that is modeling of a feedback controller with PSO technique. Okay. So this PSO technique was implemented here in this full bridge inverter topology. Okay. This is modeling of PV module. This already we have concerned, and this is basically the complete block diagram of implementation of PSO based system. Okay, where we can say this is the PV module. This is a PSO based controller. Then this is DC to DC converter. That is green one is DC to DC converter. This is the inverter, and this is the MPPT system. Okay. So this complete system is a photovoltaic system considering PSO based algorithm. Okay. This is the hardware which we have installed in our department. Okay. This is the inverter. These are the batteries. These are the solar panels which are being erected at the rooftop. Okay. This is the inverter. Okay. And these are some of the outputs. The major thing which I have to discuss with you regarding the results, that is main. These are the output, that is the MPPT voltage and current, battery voltage. Okay, these are the output from this PSO controller. This is PWM signal generated. Okay, these are the outputs, that is voltage and current outputs. This is the THD, total harmonic distortion, and we have done one exercise on that. Okay, that is that particular system is of 1 kilowatt. Okay, and that particular system we have tried for different types of load. Means naturally these loads are means this system we have connected to only lights and fans. Okay, and we tried to analyze that particular system by considering different loading conditions. Means you can see here this particular column, it is consisting of load. So I have started from this particular load, that is 5 means just by means it was a simple operation that by putting on this particular loads, that is first I have considered 2 fans, 2 lights. Okay, then 3 fans, 3 lights. So according to that, this load varied. Okay, so initially I have considered 545 and start increasing till, as it is having a capacity of 1000 watt, I increased it till to 910. Okay, then of course it will have a voltage, output voltage and current, and based on that I have calculated this crest factor. Okay, basically you must be knowing that this crest factor tells you about how basically your how perfection regarding your sinusoidal output you are getting from that inverter. Okay, that is the, if you consider the ideal value of a crest factor for a absolute sinusoidal signal, it is 1.414. Okay, so we will discuss these results in the subsequent slide. And THD, that is earlier the THD means when I was considering at half load, I was getting this THD, that is 14.8. Okay, but as I go increasing this particular load to its rated capacity, okay, there was a drastic decrease in the THD. Okay, means one thing we can see here, that whatever capacity which we are considering for a particular system, we have to consider that particular capacity. Okay, means हमको उस particular system को उसी rated capacity पे चलाना है if we want an efficient system. Okay, and then there the error band ratio was calculated. Okay, So from this, we can draw a conclusion that by considering PSO technique in MATLAB Simulink model, the PWM signal were improved based on the output voltage and current sensed by the controller. The MPPT technique was able to stabilize the DC signal for charging of the battery at nearly 28 volts. That is the battery capacity which we have considered, it was 24 volt 200 Ah. Okay. So you must be knowing that whenever we are charging the battery, that is a 24 volt battery will require slightly higher voltage, that is 26-27 volt, to charge the battery efficiently. The output AC voltage and current of the inverter was very close to the sinusoidal. Also, the current THD value was 1.78%, which was below IEEE standard. The hardware prototype model for 1 kilowatt was also experimented and investigated. As per the observation shown in the table for 1 kilowatt prototype, the crest factor, which is what? It is the ratio of peak value to effective value at different load values, were very near to the ideal value of 1.414, which gives the perfection in sinusoidal output. Okay. So this was basically from my side. Okay. So this was a small work which we have basically done in our department. Okay. So hereby I conclude my presentation. We can go for the queries. If you have any queries, you can ask.
So we request participants, please ask your question. Sir, one question in chat box.
Yes, sir.
How much voltage generated by the PV cell? Maximum value.
Basically, PV cell is generating, means it is a basically PN junction. Okay, means it is simply working as a diode. Okay, so it may be 0.7 volt, like this something. Because when we consider a module, this module is basically a combination of series and parallel combination of PV cell. Okay, so the panel rating, okay, means whether it may be a voltage or current or a power, that will be decided. Means if I am considering 80-watt panel, okay, I have to consider this VOC and ISC. Okay, the voltage and current. So whatever voltage, means if I am considering nearly 18 volt, then I have to arrange that cells such that for 80-watt panel, I should be able to get that is 17 or 18 volt with the combination of cells in series and parallel. So of course, one cell, it generates 0.7 volt, such as diode, means it like a diode.
Okay. Any question again? Please ask. If you have any query, please ask. Okay. Shall we conclude, sir?
Yes.
Okay. So thank you very much, Dr. Prashant Thakre, for conducting a nice lecture today on day 3. You have also already discussed designing, modeling of PV system, different power converters, different MATLAB modules. Also, you have discussed, and their results also discussed. Thank you very much once again. Next is some announcement. Our practical session will start at 2:30, but you join 2:15. Topic is grid synchronized using PLL and FLL by National Infotech Surat. Please join at 2:15. Okay, and today we will give the feedback attendance link on chat box only, not on the WhatsApp. Okay. Okay. Thank you once again. See you, and we will join at 2:15.
कोई क्वेश्चन आया देखो।
Okay. 1 minute.
कुछ तो ये पूछे नहीं, इसका नहीं।
one query when you have taken the screen. Okay, I have just taken the screen. I have just taken the screen. Mr. Ghosh, I will add you. Mr. D. Ghosh, I will add you. Don't worry. Okay. Don't worry, Mr. Ghosh. I will add your name in my attendance. Okay. I have just taken this. It is just randomly I have taken this attendance. Don't worry.